Now, when working with fractions, we often consider fractions as a division symbol more than anything else. So, for example, when we look at the fraction 3/4, we have something that's known as a numerator, which is the top number of a fraction, which in this case is the 3. We have a bar of our fraction, and we have a denominator, which is the bottom number of our fraction. In this case, it's the 4. And what we know from the previous video is this is essentially a way to represent, if I want a visual representation of it, we're dividing an object into 4 equal portions. And in this case, we have 3 of those 4 portions shaded. That's a visual way that we can represent them. Now, if you think about that, to do that, what we actually did was divide our original object into 4 pieces. So that's what the reason why I guess we can think of fractions being like division problems. Another way that we can actually represent 3/4 is we can say this is actually equal to 3 divided by 4. And because of that, we can actually solve this into a decimal form. So fractions do have equivalent decimals. So if we perform this 3 division by 4, and I'm just going to sort of give this answer for now, we end up seeing that the equivalent is 0.75. And it's really important to understand that fractions do have divisional equivalencies. So let's have a look at some different division problems. Now we're going to go back to whole numbers for now because we're going to deal with decimals a little bit later. But when we see fractions, we can think of them as division, and we often write division problems with a fraction form rather than the division symbol. So it's the reason when you start to move through your schooling in maths, you won't see division symbols appear that often anymore. Instead, you'll see them replaced with fractions. But we can solve those fractions, and we can solve them like as follows. If we've got this 10 over 5, our numerator of 10, our denominator of 5, we can think of this problem as, not 5, what am I thinking? We can think of this problem as 10 divided by 5. And of course, we can solve 10 divided by 5, because 10 divided by 5 goes in it twice, so it has a solution of 2. And we can keep applying that with any kind of fractional problem that we've got here. So if we've got 16 over 2, that's the same as saying 16 divided by 2, which goes 8 times. We can also do it with negative numbers as well. So if we've got negative 30, for example, and we're dividing negative 30 amongst by 6, I should say. The way that I like to think of these kind of negative kinds of problems a little bit is we've got a debt of $30, and 6 people need to contribute to that debt. So in other words, each person needs to pay $5 to pay it off. But this is negative 30 divided by 6 is going to be negative 5. We can then also represent numbers in terms of fractions. So if we've got a division problem, we can put it back as a fraction. So negative 3 divided by 4, we can write as negative 3 over 4. The reason why we put the negative symbol at the front is just because we know that this becomes a negative number. If we have something like negative 2 divided by negative 7, this is what it appears like. But we also know that when we divide a negative by a negative, the solution becomes positive. So we can actually rewrite this as just being 2 over 7. But the main thing to get out of this video is to understand that fractions can be thought as division, and division problems can be thought as fractions. And it's often we move away from using the division symbol as we start to move into high school mathematics. So start to get comfortable and confident with representing division problems as fractions.